Hey, pre-calc. Today we are going to talk about how to graph transformations of these functions. So yesterday we looked at a few different parent functions, and now today we're going to work on what happens when it's not like the general function. Okay, sometimes it gets shifted up, down, left, right. Okay, so first our vertical shifts are going to happen. So vertical means it's going up or down, and if it's up, then that means something's added to the end. If it's down, something is subtracted. So sometimes it'll be like here, x squared, that's like our quadratic. This quadratic is shifted up 5. Okay, sometimes it's going to be obvious what the function is. Sometimes it's more generic. If we look over here, it's just f of x minus 3. So whatever the function was, it's minus 3 or down 3. Okay, so we don't know exactly what the function is, but whatever it is, it was down 3. Okay, now the horizontal shift. This is your right and your left. And you got to be careful on this one because when we're graphing, positive is to the right. However, when we shift, because it's inside parentheses, that's negative makes it go right and positive makes it go left. It's kind of the opposite of what you maybe would expect. So if we look at this first one, x plus 2 squared, that one is actually left 2. This last one, y equals f of x minus 6, okay, that would be to the right 6. So once again, it's kind of more generic over here on this side. We don't know what it's going to look like, but we know whatever it originally looked like, it's right 6. This one we actually could graph if we wanted to. Okay, so now flips or reflections. Okay, this is going to involve a negative sign in front of the function somewhere, and it's kind of depends on how it looks. If we look at this first one, negative x squared, that's going to flip it up or down. So flip it up or down if it's in front. However, if it's inside the parentheses, like on this one, it would flip it to the left and the right. Now with a quadratic, that's not going to change it much because a quadratic is symmetric. So if it flips in left and right, nothing really changes. However, with some functions, it might. So once again, if it's at the front here, that flips it up and down. So if it was opened up, now it's going to be opened down. Okay. And with our function over here, this last one, that's going to flip it left and right. Okay, so now this one, stretch or compress. Okay, if there is any number in front, now that's beside that negative sign, okay, because I know that's technically a -1, but any number in front, it either stretches or compresses it. So this first one, if there's a 3 there, that means it's going to be 3 times as tall. And it's going to be kind of tall and skinny, you could think of it as. All right, if there's a 1/2 here, it's going to be half as tall. And that one will look short and fat. Kind of looks like it got squished maybe. All right, now the next one. This one is going to be 2 times as tall. And once again, it'll be tall and skinny, okay? And then the final one, 1/3, that'll be 1/3 as tall and short and fat. All right, so if we look down here, it says for each function, describe the transformation. And once again, some of these are very obvious what they are. Like this is a quadratic, over here is a quadratic. Some of them are more generic with just an f of x. So this first one, only one transformation happens. It's inside the parentheses, so that's going to be left 1. Okay, on our next one, it's going to flip. It's inside, so it's going to flip to the left and the right. Our next one, two different things are going to happen. It's going to be 2 times as tall, and then it's also going to go left 3. All right, number 4 here, that negative at front makes it flip up and down, and the plus 4 means it will go up 4. And when I say these transformations, these are all from like the original function. So for this one, the original is y equals x squared. For this one, it'd just be y equals f of x. Okay, so now for our next one, it's going to be half as tall. It's going to be down 7 because of the negative 7 at the end. And it's going to be left 3. All right, our final one also has 3 things happening. It's going to be flipping up and down. Then it's going to be left 8 and up 1. All right, so on the back here now, I said to tell the shape, the rule, and the transformation. I meant to edit that and I didn't. So go ahead instead. Let's just name what it is, and then we'll tell the transformation. Okay. So the shape here, this first one would be a square root. And it's going to go left 3. Our next one, hopefully you see here, it's absolute value. Okay, it's going to flip up and down. Then it's going to be 5 times as tall. And then finally, it's going to go up 8. All right, this last one on this row is the reciprocal function. It's going to flip up and down. Oh man, that was terrible. And then it's going to move down 5. All right, our next one, the shape would be a parabola. You can either put parabola or you could call it a quadratic. And it's going to go down 2. All right, this next one is a square root. It's going to flip up or down and go down 1. And then our final one is a cubic, and it's going to flip sideways here. So left to right. All right, so on this next one, this shape is going to shift. We know it shifts left 4 based on the fact that that is underneath there. It's like it's in the parentheses. Okay, this was a reciprocal. So normally it looks something like this. Okay, and it is shifting left 4. So I'll leave that one there. If we go left 4, instead of 1, 1, and negative 1 being the points, those will have to go left 4. So 1, 2, 3, 4 right here. And then right there, those are the target points. So let me go ahead and erase the red. And now it's going to end up like this. And we'll talk more about this later, but there is a spot where it cannot exist. That would be on the line where x equals -4. And the reason why it can't exist there is if I plug in a -4 here, if I plug in a -4 there, I'm going to get -4 plus 4, which is 0. 1 over 0 does not work. Okay, y also cannot be equal to 0 because if I would set it equal to 0, then when I'd multiply this, I'd get 0 equals 1, which that's not true. Okay, so now our final one, this is a cubic, and it's going to go up 1 and right 5. So to graph these, you could use your parent function to start with, or you can make a t-table, whatever's easier. It works both ways. So we know our parent function was at 0, 0, 1 cubed is 1, 2 cubed is 8, and then -1 cubed is -1, -2 cubed is -8. And we got our parent function. Now we are moving it up 1 and right 5. So either you can take each of those points and just count them up 1, right 5. So starting in the middle, up 1, right 5. The next one, up 1, right 5. Next one, up 1 and right 5. Next one, up 1, right 5. Up 1, right 5. And we get this green one is our new shape. And that works. If you are not comfortable shifting it like that, you also could, then I'm going to erase the original because this is not here. If you're not comfortable shifting it like that, you also could make a t-table and plug in different values, okay? So that would also work. If you want, you can make a t-table, plug in different values, okay? So today, one final thing I want to talk about, it's not in your notes, it's your Delta math assignment, and I want to show you an example of two different types. So the first section here is the discovery, and you have to do a few of these. Now, our job is to try to get this function onto the dotted line. And you'll notice I can adjust it. So if I change this to a negative, it flips it upside down. Okay. In our case, we want to open it up, so I got to change it back. And then notice up here, it reflects what is actually happening. So now, if I want to shift it to the left, I need to remember I need to have a positive. So like +3, I hit enter, it shifts over. I wasn't quite far enough. I got to change it to +4, and it shifts over. Now I want it to go up. Remember, if I go -2, it shifts down. So I want to go +2, and then it will shift up. And as you can see, it is now on. It says that is correct. You may now press submit, and you're done. Okay, so then you just submit your answer. Now, that's one type. You'll have to do about 5 of those, I think, or get 5 correct. Now, this next one, it might look a little intimidating because we haven't done one with cube root, but you guys, and you won't all have cube roots, but some of them might be, but it's just the same idea. We shift it, it says +3. Now, what you want to do, if you grab the origin here, this green dot, it will move the whole thing. So you can see the dotted line tells us where it originally was. It was right here. I need to shift it +3, so up 1, 2, 3, and just let it go, and it's there. Now notice, if I grab this blue dot, it changes the whole thing. So I don't want to do that. Let's see, it was right there. Instead, just grab it by the green dot. That's where it originally was. We shifted up 3, let it go, and that's how you can move it around, and then you submit your answer, okay? And say yes. And we got it. All right, so please let me know if you have any questions. Get the Delta math assignment done for today, and hope you guys have a great weekend. Don't forget about the quiz tomorrow.